This video will explore standard MGSE6.G.4. The standard requires students to represent three-dimensional figures using nets made up of rectangles and triangles. The nets will be used to solve for surface area of mathematical and real-world problems. The video will show how teaching the standard builds from the area of two-dimensional shapes and composite shapes being used as the foundation for surface area of three-dimensional shapes. Finding the area of compound shapes is a sixth grade standard that can help students make the connections to finding the surface area of nets, because they must decompose the shape into rectangles and triangles to find the total area. The Georgia Standards of Excellence framework task, What's My Area, is a formative assessment lesson that could be used to assess student understanding of finding the area of rectangles and triangles in a composite shape and introduce the concept of surface area. To begin the task, students were instructed to decompose the compound shape into rectangles and triangles.
I decomposed my shape by having on the top a triangle, under that a square or a rectangle, and right under that a larger rectangle. On the left I have a triangle, and on the right I have a triangle.
It may be a good idea to design a graphic organizer or table to assist students with the decomposition of the shape to find the area. The task prepares students for using the area of rectangles and triangles to solve for total area. Students should be able to discuss applying the formula of the two-dimensional shapes to solve for area as in this video clip.
The shape 2 and 3 are rectangles. To find the area of a rectangle, we have to multiply the base times height, or the length times width. So for the second rectangle, we got 3 times 3.5, and the third rectangle, we got 12.5 times 3.
Shape 4 and 5, as well as 7 and 8 are triangles. So all of their formulas are base times height divided by 2.
The student provides positive and negative feedback to his peers. In his comment, he mentions the common mistake that is made when solving for the area of a triangle.
Positive, all his measurements were accurate, but his negatives were for shape 4 and 5. He didn't divide by 2. That messed him up, so he got the wrong answer.
After building the foundation of the area of two-dimensional shapes and composite shapes, students are ready to explore the nets of three-dimensional shape. The skill of decomposing and finding the area will translate to the naming of the nets and calculating the surface area. Students should be allowed to manipulate nets and be exposed to real-world examples. In the following clip, students will explore the nets to incorporate the standard and begin the discussion of surface area.
What shape are the faces and how many?
There's 4 triangles and 1 square.
1 rectangle. How do you find the area of the total shape? Of the shape?
I have you multiply the triangle length times breadth, and then you multiply by 4, and you multiply length times breadth with the rectangle and add that with the triangles.
You forgot to divide the triangles by 2.
Oh, yeah.
There are 6 rectangles to this shape, and to find the area of the shape, we have to multiply the base and the height. And when we get the answer, we have to multiply that by 6 because of how many sides there are.
So are you saying all sides are equal?
Oh, no. Let me see.
So if they're not all equal, what would you have to do?
You have to find the area for each individual shape of the rectangle,
And then do what?
and then add all of them together to get the total area.
A resource that allows students to continue the discussion of nets in three-dimensional shapes is the Learner.org site, which allows students to see the net, the three-dimensional shape, and the manipulation of the net into a three-dimensional figure. In Standard, G.4, students must use knowledge of nets to represent three-dimensional figures and solve for surface area. The Georgia Standards of Excellence framework task, finding the surface area, is a good task to support student understanding of the concept.
What you guys get for the area in the middle?
20 millimeters.
The ones to the left and right are the same, and their height is 6 times the base 5 is 30, and divided by 2 because that's the triangle's area formula is 15 millimeters each. So 20 plus 15 plus 15.
The ones on the top are the same.
Their base is 4 millimeters and their height is 8 millimeters.
The pyramid, because the base shape is a rectangle. Is a rectangle, and there's triangles to the side make a pyramid, and it's called a rectangular pyramid because the base is a rectangle.
In applying these concepts to solving real-world problems, teachers should look for activities, tasks that make meaningful learning experiences that will solidify student understanding. The Story of Buddy is a short poem that allows students to apply their understanding of nets, surface area, to a real-world concept. In addition, it can be used to make connections to language arts. As the hook, students are reading the poem and following along as they watch a short video clip on the Story of Buddy. The Story of Buddy task questions give students experience solving for surface area with real-world and mathematical problems. This student is applying her understanding to solve for the surface area by using the formula for a rectangular prism and using the information from the poem identifying the dimensions of the walls. With this standard, students should be encouraged to solve problems using their mathematical reasoning of surface area in rectangular prisms, which should lead to variation in strategies, but the same answer. The carpeting and painting calculations are another extension of the task to further incorporate real-world application. Real-world application for these concepts is very important to make meaningful connections for students with surface area and nets, and provides concrete representation of concepts that can appear abstract to students. Students explained and demonstrated their answers to another class in the preceding videos. The explanations are evidence and expectations of student learning of the standard.
The front and the top and bottom is 10 and 15, so you multiply that by 2 to get 300. The sides are 15 and 8, so you multiply that and you times it by 2 to get 200. And then the front and back is 10 and 8, so you multiply that and times 2 to get 160.
And to get the surface area, you have to do what?
Add them all up. So once you add 160, 240, 300, you get 700 feet squared.
The cost of paint is $1,039.25.
Okay, so let's go back up here. You have 700 minus 150. You have 700 minus 150. Explain why you minus 150 here.
It's because the 150 was the, can you see this? 150 was the cost of the floor, and we weren't supposed to paint the floor, so we just subtracted the one area of the floor to the total surface area. We got 550, and then we multiplied it by $1.89 because in the text it says the painter was $1.89 per square foot. So we multiplied both of those, and then we got $1,039.05.
The carpeting, we multiply 150 by $3.50 to get $425.
The task also allowed for the opportunity of students to discuss the errors in their calculation and work.
We We got this one wrong because we accidentally measured the floor too. And you're only supposed to paint the 4 walls and the roof, so.
Additional resources that can support the teaching of Standard 6.G.4 have been provided on this slide along with the links. The illustrative mathematics task, the 3 hidden rectangles, allows students to practice the decision on how to decompose a composite shape into rectangles. The surface area and volume tic-tac-toe board is an example of an activity by Carolyn Coyle to differentiate the product to meet various learning styles. All wrapped up in surface area fun is a teaching lesson provided by CPOMS and is a good resource to guide the creation of lesson plans for the standard. The Surface Area Activity Builder by Desmos provides a demonstration that is interactive and progresses from 2-dimensional rectangles to 3-dimensional rectangular prism and then discusses the net.